So let me start. This is a final report of STAT404. I'm Byung-Jun from the Department of Computer Science and Engineering. Recent days, humanity is seeing rapid advances in AI. Nevertheless, we cannot trust the model 100% of the time. The figures is the Tesla, and there was an accident where an autonomous model mistook the side of the trailer as the sky and collided with it. To solve these problems, AI itself must be able to model uncertainty. To ensure AI stability in real-world scenarios, we would like to learn more about Bayesian machine learning. Our research goal is to understand the concept of Bayesian machine learning. Then, what is Bayesian machine learning? Bayesian machine learning is a statistical approach in machine learning that applies Bayes' theorem to update the probability of a hypothesis as more evidence becomes available. It provides a framework for dealing with uncertainty in predictions. A modern machine learning is a concept that involves deep learning. Therefore, we will review the utility of Bayesian machine learning, especially Bayesian neural network, compared to the traditional machine learning approaches, and examine the applicability of Bayes' theorem in deep learning. We looked up the survey paper to learn more about the concept of Bayesian deep learning. In addition, we used the lecture materials of Professor Jin Shin of KAIST to understand the contents and refer to the implementation to be introduced later. Bayesian neural network, which we usually call BNN, is a neural net with prior on its weights. Note that Bayesian inference cannot be applied without priors. We have two choices to modeling uncertainty. First option is log likelihood, and second one is log prior. By doing these methods, our model's inference allows to model uncertainty over parameters. Here is our first experiment. We do a comparison between Bayes neural networks and multi-layer perceptron, which we usually call MLP. MLP is a standard neural network without deterministic properties, while BNN does not. Therefore, our experiment is to verify the usefulness of Bayesian statistics in deep learning. And here, in the experiment, MLP will be used as a baseline to empirically confirm the performance and the characteristics of BNN. We used wine quality data set for our lab setting. In the second experiment, CNN was used as a baseline to compare it with BNN. CNN is a convolutional neural network that has strong learning capabilities in computer vision, especially in scene understanding. Therefore, we conducted an experiment using the Cypher10 dataset that is commonly used in computer vision. The wine quality dataset in the first experiment has 4,898 instances and 11 features, and the target value is quality. The Cypher10 dataset in the second experiment consists of 50,000 train sets and 10,000 test sets with 6,000 photos in every 10 classes. Let's start with the first experiment. We implemented MLP and BNN directly from scratch to proceed with the experiment. The setting is as follows. Both MLP and BNN were prepared in the same size, and for fair evaluation, the number of epochs was learned as the same as 100 times. Here's the first experimental result. The RMS of MLP is 0.765, and the BNN is 0.975. If you look to the right, there is an uncertainty plot where the red dot is the actual target, and you can see that our model is predicting within a reasonable confidence interval. Next, the second experiment. We implemented the CNN and trained it over 50 epochs. BNN conducted comparison using an open source called PyTorch Bayesian CNN. CNN's accuracy was a 0.763 and BNN was 0.719. BNN's figure is low, but BNN's accuracy is quite low, but this is marginal because BNN is good at preventing overfitting. On your right, I draw an uncertainty plot for one image. Then let's see our major findings. The advantage of BNN is that it is robust at overfitting, as seen in the second experiment. In addition, unlike MLP and CNN, it has the advantage of being able to measure uncertainty in production. On the other hand, I would like to point out that there is a disadvantage of computational cost for training BNN, and therefore it lacks scalability. So the key point is scalability. In the LLM era, scalability is a key topic in AI research. This issue must be addressed if we want to incorporate Bayesian statistics into future deep learning as well. In addition, if Bayesian statistics are combined with self-supervised learning, the model will be able to grow itself. So self-checking for uncertainty. Finally, computational challenges also remain as a problem of Bayesian machine learning. So this is end of my presentation, and thank you.